humanity has always looked to the stars seeking answers, but sometimes the stars look back, revealing mysteries that challenge everything we know. Tonight, we explore one of the most perplexing and alarming events in modern astronomy, the interstellar object known as 3I/Atlas. Unlike any asteroid, comet, or celestial visitor we have encountered, this object has captured the attention of astronomers, governments, and private space agencies around the globe. The object was first detected in late 2019, and from the very beginning, it defied conventional understanding. Its trajectory was unlike anything seen before, and its speed and path suggested a visitor from beyond our solar system. Yet, despite its significance, the world watches in silence, a silence made even more unsettling by the lack of communication from China, a country that has rapidly become a leader in space exploration. NASA has been publicly cautious, describing 3I/Atlas in scientific terms, emphasizing its interstellar origin, its anomalous acceleration, and unusual composition. Behind closed doors, however, the situation is far more urgent. Internal NASA communications indicate updates to planetary defense protocols and recalibration of monitoring missions to account for unexpected anomalies detected on the object. Meanwhile, China has remained completely silent. No statements, no research papers, no press releases. This absence is striking because Chinese space programs have historically been highly visible, from the Chang'e lunar missions to Tianwen-1 and Tianwen-2 Mars programs. This unprecedented silence raises questions. Are Chinese scientists observing something they are not yet willing to share? Are they detecting evidence that could alter global understanding of interstellar phenomena? Or could there be other implications, potentially strategic, for Earth's safety or international space policy? As the world waits, amateur astronomers and independent observatories have reported signals and unusual light emissions surrounding 3I/Atlas. While NASA remains skeptical, these anomalies cannot be ignored. History shows that rare interstellar objects often provide critical data, sometimes about the universe, sometimes about the unexpected threats that lurk in it. Some researchers draw comparisons to Oumuamua, the first confirmed interstellar visitor, detected in 2017. Like 3I/Atlas, Oumuamua presented strange features, prompting speculation about natural versus artificial origins. Some experts even suggested the object could be a probe, a remnant of alien technology, or an unusual fragment of interstellar matter. 3I/Atlas, however, exhibits characteristics that may be even more extraordinary, raising questions about its purpose, composition, and trajectory. The stakes are higher now because NASA itself faces operational delays and partial shutdowns, which can affect the ability to respond quickly to emergent space threats. Meanwhile, the lack of international collaboration leaves the scientific community piecing together fragments of information from disparate sources. What is particularly troubling is the unknown factor. China's silence could mean critical data remains undisclosed, data that could change everything we understand about this object. Visual, animated trajectories showing 3I/Atlas passing through the solar system, orbit intersections, and close-ups of Earth and Mars. Some independent analysts speculate that China may have deployed advanced observational technology to monitor 3I/Atlas in ways invisible to the rest of the world. Others hypothesize that the object may contain exotic materials or even carry signatures of a non-natural origin. Whatever the truth, the absence of shared information increases uncertainty, and in interstellar science, uncertainty can translate into global risk. Today, as 3I/Atlas moves along its unprecedented trajectory, scientists continue to monitor it across multiple wavelengths. Infrared, ultraviolet, and radio observations provide glimpses into its composition, but each discovery seems to raise more questions than answers. Its acceleration appears inconsistent with known physics, and its spectral signature hints at materials not previously identified in any natural celestial object. Scientific teams across the globe have been scrambling to make sense of 3I/Atlas. Observatories in Europe, North America, and Australia have coordinated to capture every possible angle, every fluctuation in its light spectrum, and every deviation in its velocity. Using advanced spectroscopy, researchers have detected chemical signatures that suggest elements rarely found in our solar system, some of which hint at high-energy processes that challenge conventional astrophysics. While the public has been reassured that there is no immediate threat, the anomalous behavior of 3I/Atlas has prompted urgent discussions behind the scenes. NASA scientists are examining whether the object's acceleration could be influenced by unknown forces, radiation pressure, or even artificial propulsion. The possibility that 3I/Atlas could be more than just a passive celestial visitor, perhaps a probe, a fragment of advanced technology, or a vessel carrying unknown materials, is taken seriously by a subset of researchers who prefer to remain anonymous. China's silence continues to loom over the investigation. Their lack of participation in global updates is particularly jarring, given their extensive capabilities in space observation. Analysts speculate that the country may have detected anomalies that the international community is not yet privy to, anomalies that could provide a significant advantage in understanding or even interacting with 3I/Atlas. The consequences of such silence are profound. Scientific discovery thrives on transparency, data sharing, and peer review. When a major spacefaring nation withholds critical information, the global community is left guessing, analyzing partial datasets, and drawing conclusions that may be incomplete or even misleading. In a field where small miscalculations can have monumental implications, such gaps in knowledge are far from trivial. Amateur astronomers have played an unexpected role in shedding light on the object's peculiar behavior. Using high-resolution backyard telescopes, they have reported sudden flares of light, oscillating patterns in reflectivity, and transient emissions that do not correspond to standard cometary or asteroid activity. Some of these reports have been dismissed by mainstream scientific publications as observational errors or artifacts. Yet, when multiple independent sources report the same anomalies, patterns begin to emerge that cannot be ignored.